Today I'm going to show you some functions in the iSpeed Control 1 software that's ideal for a DIC user. There have been many functions added to this software to allow you to set up the camera and ensure you've got the right brightness and the right size images for DIC analysis. We understand that many DIC companies will use these cameras, and each company requires a different speckle pattern and a different save file format, and we'll just kind of cover that in the following minutes. So I've now got a iSpeed 513 camera here I've connected, and we're going to use this camera today to just give you a quick running demonstration. If you were looking to do a stereo DIC application, then you can actually take the camera and you could modify the name of the camera to be left and right, and that can be done here with modify camera settings and then general, and then you'd change this name to left or right and then press apply. So that way you can then use that as part of the save process to designate your left and right cameras. Today we're just going to run with a singular 2D DIC kind of example, and so I'll just leave it at serial number. Once we've connected to the camera, we can then move to the capture tab, and now we get a live image from the camera. I'm going to move the camera just slightly just so you can see that it's live, and so there we go, we've got a speckle image here. Now I'm sure this is far from optimal, very large dots for the resolution I'm running. I'm just running at a default frame at the moment so that I've not got noisy lights. But what I want to do here, the key here, is to show you the functions within the software that we can use to ensure you've got a good capture for DIC applications. So one of the things I want to show you first, and we can just walk through these tabs. These tabs at the top left here are kind of overlays and assistance, and the tabs on the right are the speed and the trigger and things like this. These tabs can be moved around, and you can make a whole pile of them wherever you wish. If you want them all on the right, you just move them to the right and the left, etc. So first of all, we're going to make sure that the image is exposed correctly and focused correctly. I'm using here a 105mm lens, and I can just click on iFocus, and then I can adjust my focus, and you can see that the focus obviously softens, but you can see this blue outline, and then it goes to a much redder outline here and here, and so we can walk through the focus, and we can actually use that to ensure we have a very good focus and a sharp image. We then have iExpose, and this is an overexposure and underexposure, and so if I now increase, open up the aperture, it gets too hot, and these areas here are saturated white, and then if I lower the aperture, we can see this is underexposed, this is black, but this is great because we don't care about this area, we care about this area here. And so I can then continue down and underexpose, and even the dots become underexposed. So basically we want to just come to the red and then dial it back so that we can ensure there is no saturation, which is what we've got here. So now we know that the image is now focused to its best ability and aperture set to its best ability. We can actually check that in many different ways, and so that's the first kind of setting, and then we can tune it from there. Here I've got a lot of the camera settings, and I can say I want to have an overlay of a histogram, and so I can say luminance. And we put a luminance histogram here. Now I can then double click on this to make this bigger. And now we can I'll change the aperture again, and I can bring various parts. So here we can see that if I put it to here, I'm only half filling the sensor with the white area. This is the white area, this is the black grey area here, and then dots, etc. So what I want to do is I want to push that white area up in the histogram so as it is just short of putting pixels into saturation. which is here like this. And so again, this is another accurate method of making sure we have not got saturation and we've got great ability to do correlation on this image. If you want to be a little bit more accurate, you could say, well, I don't really care about the luminance histogram in this area. I want to actually have a region of interest, and so I can say, let's create a rectangle, and I can bring it in, and I can actually just histogram this area here. And so now I can ensure that, again, my saturation is set correctly, and that there are no pixels in the peak white. You can do that for any square item. You can also do it for an ellipse as well. If you're looking at something rotating within a DIC experiment, you can also do an ellipse. Once you're finished with the luminance histogram, you can just continue clicking, and then it will get back to small again, and you can put it away if you want, or you can just leave it there, and it's great for ensuring you've still got good exposure. Another function that our customers like is line graph, and what we have here is we have the yellow line here, and we can actually put it across the image, and we can see the amplitude of the pixels. And so again, I can raise the amplitude by doing this, and you can see we're peaking out, or I can lower the amplitude and we can see the black level going down. So here we can balance this and actually make sure that we've got pixels that aren't peaking. And so we can use this to massage and exactly ensure that we've got good DIC correlation pixels. This line graph, by the way, can be as big or as small as you wish. We can make it the full width, we can make it a very narrow small area, and so then you can then sample that area however you wish. We can also make it vertical as well, in case you wanted to measure through a vertical plane. So these functions allow you to really set up your image and ensure that you're ready to do a DIC recording. We also have subsampled image, so when you're doing a fixed alignment grid for your depth plane and calibration, you can set this up, and that will then subsample, and you'll get an even grey if the pattern is correct. And so some of our customers like that. And then we've also got the zoom window, and so we can then have the zoom window. We can say we want it to be a width of, let's say, 21 pixels by 21 pixels. And now you could use this to check your correlation window size and ensure that you've got small enough details to correlate. You can see here that my speckles are way too large for correlation here, for ideal correlation. But you get the concept, is that you can then move this around and ensure that each feature is suitable. And you can drag this larger, and you can drag this around, or you can decide you want to actually just make this a little larger for general zooming, and you can then zoom that around as well. So these are very useful functions. When you're initially doing your calibration for DIC, you can save live image snapshot, and that allows you to save a TIFF from the camera to a known location, and that location is under Edit, Program Options, and then Snapshots Save folder. And so you can change that location to wherever you prefer the calibration files to be saved. In a future release, we're actually upgrading this and allowing you to save in an image file format that is in your order, i.e. you can change whether you want left first, then the frame number, etc. Or and also whether you want 8-bit TIFF or 16-bit TIFF, and so that's an upgrade that's coming along on the next release. And so we can save an image snapshot, and then that saves that snapshot to that hard drive there, and then we can now do our recording of the actual test. And so we simply hit record. The camera now goes into its buffer. This will go for quite some time until it goes to green, because we're only running at 100 frames per second in this example. And then we can press stop. So now we have the video in our review tab, and we can now scrub through that video, select the areas that we like. So let's say this is the start of the transition. We can say use current, and then we can then scroll along further to where the tear happens and say use current on clip end. And now we can see that we're going to start to save at frame 300 and then end recording at 790. So what we've defined here is where we start and end. This is our entire buffer from here to here, but we're actually going to only save the video from here to here. And so now I can go into the Save tab. I'm going to save it to my computer, my C drive. I'm going to save it in an image file format, and I want 16-bit TIFF RAW. There's a large choice of selection here. Obviously with DIC you want it to be RAW, and so I've selected 16-bit TIFFs. I'm going to save it to DIC example, and I'm going to save it to test 1. And so what we can do here is we can say in the Options tab, each DIC software package requires different orders within the file name. So it might be that you put the camera name, you then put a timestamp, it might be a bit depth, and then you can change the order of what you wish to be first, and you can completely configure your file format save. Some customers will prefer it one way and some another. So once you've selected this, you can then click OK, and now hit the Save button, and that will save those TIFF down to the hard drive and allow you to then get ready for the next test. Here we're saving straight from the sensor. When we say 16-bit TIFF RAW, that actually means that we're not processing that at all. We're ensuring that it comes directly from the sensor. Of course, it's fixed pattern noise corrected and all the corrections, so you've got a good image. But at the end of the day, it's not gone through the image processing of the camera. You've got direct from the sensor. And so you can see here that we've saved that image off, and so we're then ready for the next recording. So this gives you an overview, and so here I just want to show you a function just on the zoom functionality of the camera, just as a reminder at the end here. You want to ensure that the camera is representing pixels 1 for 1, and so you can click on this 1 to 1. You can click fit and it will fit it out, but it's a nearest neighbour mapping zoom technique that's used for speed, and so you'll end up seeing potentially lines, and so you might see lines like here and here. Just click on 1 to 1, and that makes you sure that you've got a good zoom ratio. Obviously when we save, we'll be saving it 1 to 1 anyway. So that gives you a very quick overview of the software being used for DIC analysis. Thank you.